There are several other length scales we use very often in boundary layer problems. I'll talk about some of them. First is displacement thickness. Displacement thickness. One effect of the boundary is that it can cause a decrease in flow rate. What do I mean by that? Well, let's say this is our boundary layer. Here, we take out a cross-section. My velocity profile along this cross-section will be 0 at the bottom and 99% at the top, right? 99% u. Well, we can say 99% is close to 1 enough. So we can just treat the velocity at the top of the bottom layer of the boundary layer to be u, right? 99% u equals to u. So if it wasn't for the boundary, then my velocity profile would be like what? It would be a constant velocity profile of u, right? So this part of flow rate is lost. So now we define the displacement thickness delta 1. What does the delta 1 mean? It means if you move up the boundary layer to the amount of delta 1, this delta 1, and you assume the velocity to be of a constant profile u, this part, right? The flow rate generated in that case would be the same as the flow rate in the real case, which means the area here will be the same as the area here, right? So now we can calculate delta 1. This area equals to this rectangle, right? If we subtract this part from both parts and we add this part to both parts, then what do we get? We get that this rectangle should be equal to the area of this part, right? We can calculate them separately. First, this rectangle. The area of this rectangle is what? U times delta 1, right? U times delta 1. This should equal to this thing, the area of this thing. This thing is from 0 to delta, right? This length is delta, the thickness of the boundary layer. To calculate the difference here, we need to use the capital U to subtract the real U, capital U minus U, and we integrate that. Well, to be more exact, the delta here should be infinity, right? Only at infinity will the velocity be exactly the same as U. But we said 99% is good enough for us. So we can say the difference between this profile and this profile ends just at the top of the boundary layer. So now we can calculate the delta 1. Delta 1 is just from 0 to delta 1 minus u over u, because this capital U is a constant dy. Very simple.